if I'm going to have odd number of ones in my data bit, so what I want to do, if all the 8 bits are 0, then it indicates that the data bits are not corrupted. Checksum value is 000001. So this indicates that the data bits get corrupted. So the receiver is going to reject the data. Hello friends, a warm welcome to my new session on the data link layer. I am your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So dear student, in my last session, I have discussed data link layer. Along with that, I have discussed the different kinds of issue we are going to face under data link layer. What are the issue we are going to face? That is services provided to upper layer as well as lower layer, along with that flow control, data control as well as error detection. These are the design issue we have discussed in my last session. Along with that, I have discussed what is error detection. So what is error here? Errors are nothing but the bits are going to change. That is known as errors. That's nothing but the toggled bit. In the sense 0 is replaced with 1 or 1 is replaced with 0. These kind of changes are known as errors. Along with that, I have covered how to detect the errors. In that, I have discussed single bit parity check or single parity check. So dear student, if I consider error detection mechanism, we are going to have single bit parity, along with that checksum as well as CRC. But in my today's session, I am going to deal with checksum. So what is checksum? What is the need of checksum? In my last session, I have discussed single bit parity. In single bit parity, I am going to have 8 bit of data. For that, I am going to append one parity bit. And how I am going to append one parity bit? That is based on number of ones in my data bit. Suppose if I am going to have even number of ones in my data bit, in my parity bit I am going to place 0 because I have even number of ones in my data bit. Suppose if I am going to have odd number of ones in my data bit, so what I want to do? I want to create even parity. In my parity bit, I am going to place 1. Okay, so here I am going to have only one parity bit. But if I consider checksum, I am going to have redundant bit. Based on my data size, I am going to have redundant bit. For example, if I am going to have 8 bit of data, for that I am going to have 8 bit of checksum. So here what is checksum? That's nothing but the redundant bit. Now dear student, let me to start with my session, that is checksum. So what is checksum? It's an error detection technique. It's an error detection technique. It's based on the concept of redundancy. So in my checksum, I'm going to have checksum field. And how I'm going to fill the checksum field? That is based on my data bit. For example, think that I'm going to have 16 bit of data. What I'm going to do here? I'm going to break this 16 bit of data into two different 8 bit of data. So 8 bit of data plus 8 bit of data. So it is nothing but the 16 bit of data. Fine. Now I'm going to generate checksum. What is the length of the checksum here? That is once again 8 bit. Okay, based on my data bit length, I'm going to have my checksum field. And if I consider checksum, I'm going to divide this one into two parts. One is checksum generator and checksum checker. Why I require checksum generator and checksum checker, and where we are going to apply checksum generator and checksum checker. So dear student, if I consider data communication, I must require two entities. So here two entities are nothing but the two nodes or two computer system. In that, one is my sender and one is my receiver. And at the sender side, I am going to use checksum generator, and at the receiver side, I am going to use checksum checker. So this is sender side and checksum generator is at sender side and checksum checker is at receiver side. Now let me to discuss this diagram. See here, I am going to have data bits. According to my checksum generator, what I am going to do, I am going to divide the data bit into section 1, section 2 up to section n. And what is the length of section 1? That is n bit. Here also n bit. So I am going to have section k. Okay, fine. After that, what I am going to do? I am going to perform binary addition. So here I am going to get the sum. And what is the length of the sum? Once again it is n bit. After that I am going to take the ones complement of that sum. So complements. What's the length of the data bit? It is n bits. After taking ones complement, whatever the output I am going to get, that is my checksum. Okay, fine. Now, how I am going to send the data along with checksum? According to this scenario, I am going to have data bit. For that, I am going to append the checksum. For example, if my data bit is 16 bit, after generating checksum, I am going to append 8 bit with 16 bit. And I am going to transfer the data bit with checksum. So that is termed as packet. Okay, fine. At the receiver side, what is the job of the receiver? Is to receive data bit as well as checksum. Once again, divide the data bit into number of section. See, section 1, section 2. Okay, then I am going to have the checksum value. Then I am going to have section n. Okay, fine. Now, once again I am going to perform binary addition. After performing binary addition, what I am going to get? I am going to get the sum. So what is the length of the sum? That is once again n bits. Now I am going to take the ones complement of that sum. Okay, and if I am going to get all the zeros after taking ones complement of the sum, suppose if I get all the zeros, then that indicates that the data bits are not corrupted. If I get any one in my data bit, then that indicates that the data bits are modified. So what the sender is going to do? Sender is going to reject the data bit. See, if the result is 0, sender is going to accept the data. If not, sender is going to reject the data. Now, if I consider checksum, I have checksum generator and checksum checker or validator. See, where I'm going to have checksum generator, that is at the sender side. Okay, what is the job of the sender? Is to divide the data bits into n number of blocks. For example, think that I'm going to have 16 bit of data. Okay, according to the checksum, what is the capacity or length of the data bit each section can have? That is 8 bit. 8 bit. Fine. Here it is 34 bit. So what I'm going to do? I'm going to make, or I'm going to divide 4 different 8 bits. So 8 bit, 8 bit, 8 bit and 8 bit. So what is the length here? It is 32 bit. Okay. Then what I want to do? I want to perform binary addition. Okay, I want to perform binary addition. After performing binary addition, I am going to get the sum. Now what I want to do? I want to take the ones complement of that sum. Okay? Fine. Now, whatever the result I am going to get, that is my checksum field or checksum value. Now, the job of the sender is to send the data with the checksum. So, it is 32-bit data along with 8-bit checksum. So, what is the length of the data now? It is 40-bit. Along with 32-bit data bit, we are going to append 8-bit checksum value. Okay, fine. Now, at the receiver side, receiver is going to receive the data bits with the checksum. Now, the job of the receiver is to perform binary addition. Okay. After performing binary addition, whatever the summation we are going to get, for that I want to take the ones complement. So, I am going to take the ones complement of the sum. After taking ones complement, okay, whatever the result, that is checksum I am going to get, if all the 8 bits are 0, then it indicates that the data bits are not corrupted. If any one of the bit holds the value 1, then that indicates that the data bits are get corrupted. What is the job of the receiver? That is reject the bit. If all the zeros, then receiver is going to accept the data, otherwise receiver is going to reject the data. Now, let me to consider the example here. Think that I have the data bit 1 0 1 0 1 0 0 1. Okay, fine. Now, I am going to have another data bit, that is 0 0 1 1 1 0 0 1. Okay, so this is my section 1 and this is my section 2. Okay, fine. According to checksum, what is the length of my data bit? It is 16 bit. Okay. Now, what I did here, I have divided 16 bit of data into 2 8 bit of data. Then what I want to do? I want to perform binary addition. So, for that, I want to consider the truth table. See here, if I consider binary addition, it is for 2 input. Okay, so A and B are the 2 input. A and it is my B, and I am going to have sum and carry. Okay, fine. So, what are the possible input combination I can have here? 2 to the power 2, that is nothing but the 4. So, it is 0 0, it is my 0. Okay, when I add 0 plus 0, sum is 0 and carry is 0. Okay, fine. Then what is my next number? It is 1. How to represent? 0, 1. So when I perform binary addition, that is 0 plus 1, sum is 1, carry is 0. Okay, fine. Now, I'm going to have 2. How to represent 2? That is 2 divided by 2. 2 ones are and 0. So, how to represent 2? That is 1, 0. Fine. When I perform binary addition, 1 plus 0, sum is 1, 0 is carry. Now, 3. How to represent 3? 3 divided by 2. 2 ones are 1 carry. So, 3 is nothing but 1, 1. Okay, when I add 1 plus 1, it is 2. But how to represent 2? 1, 0. How to represent 2? 1, 0. So, my sum is 0 and carry is 1. Well, my sum is 0 and carry is 1. To perform binary addition, you have to remember this table. Okay, fine. See here, what's my first data bit? 1 plus 1. So, 1 plus 1, it is 2. So, 0, sum is 0, carry is 1. 0 plus 0, it is 0. Then 0 plus 1, it is 1. Now, 0 plus 0, it is 0. 1 plus 1, it is 2. So, sum is 0, 1 is carry. So, 1 plus 0, it is 1. 1 plus 1, it is 2. So, it is 0, sum is 0 and 1 is carry. 1 plus 1, it is 2. 2 plus 1, it is 3. How to represent 3? That is 1, 1. So, here 1 is my carry and 1 is my sum. So, I am going to write the sum here, carry here. 0 plus 0, it is 0. 0 plus 1, 1. And last bit 0 plus 1, it is 1. Over. So, this is my sum. This is my sum. According to checksum generator, after finding sum, I want to take 1's complement. So, what is 1's complement? If I am going to have 0, I am going to write it 0 as 1. In the sense what? 0 to 1 and 1 to 0. Okay, if I have 0, I am going to write 0 as 1. And if I have 1, I am going to write that 1 as 0. Taking complements of this bit is known as 1's complement. See here, I have 0. So, what's the 1's complement of 0? It is 1. Now, I have 1. What is the 1's complement? It is 0. 1, 1, 1, 0, 0, 0 and 0. So, how many bit? 8 bit. Okay, so 8 bit. Okay, fine. Now, what is the job of the sender? Is to send data bit with the checksum. So, what is the data bit? 1, 0, 1, 0, 1, 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1. For this, append the checksum. What is checksum value? 0, 0, 0, 1, 1, 1, 0, 1. Okay, fine. Now, the receiver is going to receive this data bit along with the checksum. So, this is my checksum generator. Okay, fine. Now, if I consider checksum validator, or checksum, checker. Okay, fine. See here, what is the data bit? 1 0 1 0 1 0 0 1. Okay, fine. Then 0 0 1 1 1 0 0 1. Okay, what is my data bit? 3 zeros, 1 1 0 1. Okay, fine. So dear student, see here, this is my section 1, this is my section 2, and this is my checksum value. Now I am going to perform binary addition and I am going to consider first bit. Okay, fine. If I consider first bit, see here, 1 1 1. 1 plus 1, it is 2, 2 plus 1, it is 3. How to represent 3? 1 1. So sum is 1 and carry is 1. 0 plus 0, it is 0, 0 plus 0, it is 0, 0 plus 1, it is 1. Next, 1 plus 0, 1, 0 plus 0, it is 1. Okay, fine. Now, once again, it is 3. That is 1 plus 1, it is 2. 2 plus 1, it is 3. How to represent 3? 3 divided by 2. Okay, 1, 1. Now, 1 is carry and 1 is sum. So, sum is 1 and carry. 1 plus 1, it is 2. 2 plus 1, it is 3. So, it is 1, 1 carry. So, it is once again 3. So, 1 is sum and 1 is carry. 0 plus 0, it is 0. 0 plus 0, it is 0. 0 plus 1, it is 1. Okay. Now, 1 plus 0, 1. 0 plus 1, it is 1. So, this is my checksum at the receiver side. Okay, fine. Now, what I want to do, I want to take the ones complement of this. So, if I take ones complement, 0, 0, 0, 0, 0, 0, 0 and 0. Okay, see here, all the bits are 0. So, the data bits are not corrupted. This indicates that the data bits are not corrupted. So, what the receiver is going to do now? Receiver is going to accept the data because the data bits are not corrupted. Suppose, so dear student, instead of this 0, if I am going to have 1, then what's the meaning here? The checksum value is 0000001. So, this indicates that the data bits get corrupted. So, the receiver is going to reject the data. So, dear student, let me to consider second example here. Think that I have the data bit 1, 0, 0, 1, 1, 0, 1, 0. Oh, fine. Then 1, 0, 1, 0, 0, 0, 1, 1. Okay, this is my data bit. And where I have this data bit in my sender side. Now, what is my job? I want to perform binary addition. So, 0 plus 1, it is 1. 1 plus 1, it is 2. How to represent 2? 2 ones are 2, remainder 0. So, here this 0 is nothing but my sum and this 1 is nothing but my carry. Okay, fine. So, sum is 0, 1 is carry. 0 plus 0, it is 0. 0 plus 1, it is 1. 0 plus 1, 1. 0 plus 1, 1. 1 plus 0, it is 1. It is 0. Okay, fine. Now, 1 plus 1, 0 is my sum and 1 is carry. Over. And if I consider this data bit, if I consider this checksum field, I'm going to have 9 bits. But what is the length of my checksum? It is 8 bit and I'm going to have the carry. So what I'm going to do? I'm going to bring this carry here and I'm going to write it here. Okay, fine. Now once again perform binary addition. So 1 plus 1, 0 sum, 1 carry. 0 plus 1, it is 1, 1, 1, 1, 1, 0, 0. So what is the length of the checksum field? It is 8 bit. Now what the sender is going to do? Sender is going to send the data bit along with this checksum field. Okay. Now receiver is going to receive the data bit 1001 1010. Over. Now another one 10100011. Okay, then I want to add checksum 00111110. Now what I want to do? I want to perform binary addition. So 0 plus 1, it is 1. 1 plus 0, it is 1. 1 plus 1, it is 2. 2 plus 1, it is 3. How to represent 3? 2 ones are 1 carry. 2 ones are 2 and 1 is remainder. So this is my carry and this is my sum. Okay, sum is 1 and carry 1. Okay, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, it is 2. So 0, sum, 1 is carry. So it is 3, 1, 1 carry. So once again it is 3, 1 and 1 carry. So here 1, 3, once again 3. So 1, 1 carry. Okay, fine. See here 0 plus 0, it is 0, 0 plus 0, it is 0, 0 plus 1, 1. Now it is 0 plus 1, 1, 1 plus 1, it is 2. How to represent 2? Sum is 0 and 1 is carry. So I'll write carry here itself. Okay, fine. And if I consider here how many data bits I have? Total 9. But what is the length of checksum field? It is 8 bit. So what I want to do? I want to bring this carry here. Now I want to perform binary addition. Now 1 plus 1, 0, 1 carry. 1 plus 1, 0, 1 carry. It is 1 plus 1, 1 plus 0, 1. 1, 1, 1, 1, 0. 1. Okay, fine. Now, what I want to do? I want to take the ones complement of this. 1, 1, 0, 0, 0, 0, 0 and 1. See here. My data bits are get corrupted. My data bits are get corrupted. So what is the job of the receiver is to reject the data, because whatever the checksum I got, in that I'm going to have the ones. In my checksum field, if I'm going to have all the zeros, then that indicates that the data bits are not corrupted. But here the data bits are corrupted. So what I want to do? I want to reject the data. So dear student, in my today's session, I started with what is checksum. Along with that, I have discussed, okay, some of the example problems. But in my next session, I'm going to deal with polynomial codes. That's nothing but the CRC. That is nothing but cyclic redundancy check. Anyway, dear students, let's meet in the next session with the new concept, that is CRC, that is cyclic redundancy check. Until that, keep watching and keep learning. Thank you.